Hello and welcome back to the session. So today we will be dealing regarding nomenclature of optical isomers. So for nomenclature of optical isomers there are two methods. One is TL system and another is RS system. So what is DL system and what is RS system? So DL system, it is one of the most oldest and most commonest method used for assigning configuration to a given molecule. So this DL system is again defined by two ways. One way is hydroxy acid or amino acid convention and another is sugar convention. So what is meant by hydroxy acid or amino acid convention? So here the molecule is defined for D and L isomer. D isomer and L isomer. So what is D isomer? If the specified group is present on right hand side, then that isomer is defined as D isomer, and if the specified group is present on left hand side, then it is defined as L isomer. L for left while R is for D isomer. So in case of hydroxy acid or amino acid convention, let us take an example. So hydroxy and acid group. So you can see here hydroxy group and this is an acidic molecule. So here hydroxy group is present on right hand side, while in this case the hydroxy group is present on the left hand side. So clearly we can define this isomer as D isomer, while this isomer, because of presence of hydroxy group on left hand side, is defined as L isomer. And for amino acid convention, here the important factor is presence of amino group. So you can see here amino group, this is amino acid and this is also an amino acid. So your amino group is present on right hand side, while here amino group is present on left hand side. So clearly we can define that this isomer is D isomer and this isomer is L isomer. So this is how we define the hydroxy acid or amino acid convention of DL system, to define whether the isomer is D or L isomer based on presence of hydroxy group on right hand side and left hand side respectively, and based on amino group, that is whether it is a D isomer if it is present on right hand side, and if it is present on left hand side of the molecule, then it is defined as an L isomer. So now how to define a sugar convention? Sugar convention, that is in DL system. So as you know, sugars are polyhydroxy aldehydes or ketones. These are polyhydroxy aldehydes and ketones. These are sugars. So one of the simplest sugar is glyceraldehyde. You know, this is a structure of glyceraldehyde, and So you can see here, this is a sugar molecule, this is a glyceraldehyde molecule. So now how to define whether it is a D isomer or L isomer. Here also we have to take the position of hydroxy group into account. So here you can see the position of hydroxy group is on right hand side. So we have to define this as D glyceraldehyde, while the position of hydroxy group is on left hand side. So we define this as glycerol L glyceraldehyde. So position of, again here also position of hydroxy group, but this is only related to sugar molecules. This is not related to any other molecules. So this is how we define the DL system of nomenclature. That is based on hydroxy acid or amino acid convention, that is hydroxyl groups position whether on right hand side or left hand side. If it is present on right hand side, it is known as D isomer, and if it is present on left hand side, it is known as L isomer. Similarly, position of amino group on right hand side D isomer, and position of an amino group on left hand side is known as L isomer. So to define sugar convention, we also define the position of hydroxy groups. Position of hydroxy group on right hand side, this is known as D-glyceraldehyde, and if it is on left hand side, then it is known as L-glyceraldehyde. Now let us see the second system of nomenclature, that is RS system. So this system was defined or was proposed by Can, Ingold and Prelog. So these three scientists have defined RS system of nomenclature. So these, as the DL convention we had seen, it is specifically for hydroxyl groups or amino groups or for sugars. So only these three molecules can be defined by DL system. So other molecules cannot be defined by DL system. So in order to overcome the drawback of such system, this RS system was proposed by Can, Ingold and Prelog. These people defined this RS system based on priority. So priority in terms of atomic number. In terms of atomic number, that is, the highest atomic number atom gets high priority. High atomic number atom first priority. High priority or first priority, and low atomic number atom will get second or next priority. So this is based on all priority. To define RS system, certain set of rules have been defined. Certain set of rules have been defined. So what are these rules? So the first rule is, if four atoms attached to the chiral carbon, four atoms attached to the chiral carbon are all different, then the priority depends on the atomic number. As we already learned that the atom with the high atomic number will get first priority, and the atom with the low atomic number will get second or the next possible priority. Here we can see an example. If we take a chiral carbon, this is one molecule and the other. So now we have to define the priority. So these are hydrogen, iodine, bromine and chlorine. So if we see the halogen list of halogen, we get on the topmost priority with the low atomic number is fluorine, then chlorine, then bromine, then iodine. So here iodine has highest atomic number, so now the priority will go with the iodine, then with the bromine, then with chlorine. Obviously we know that hydrogen is the least atomic number weight, so it will get the last priority. While in this case, again iodine first, bromine second, chlorine will be third and hydrogen will be fourth. So if we see the movement of this molecule, so iodine, bromine, chlorine and hydrogen. Well, here it is iodine, bromine, chlorine and hydrogen. So if the molecules or the priorities, the atoms are present on the priorities in left hand direction. This is left hand side direction. This is assigned as S isomer. While if these are present on the right side, this is right hand side. This is a left hand side isomer. So this is R isomer, and this is left hand side. So this is S isomer. So if we rotate the priority list, this will rotate from the left hand side to right hand side. So this is S isomer, and here if we rotate the list from right hand side to left hand side, so this is R isomer. R is right isomer while S is left isomer. Here you can define R right side or rectus, while S is left hand side or sinister. So here the priority list is moving from the right hand side, and here the priority list is moving from the left hand side. So this is an S isomer while this is R isomer. So let us see now the second rule. So the second rule defines that if the relative priority of the two groups cannot be decided, then the comparison between similar kind of groups attached to the chiral center is done, and then the other atoms of the groups are given priority accordingly. So let us see how does this rule work. So now here you can see similar kind of groups. So this is also methyl and this is an ethyl. So these are both saturated groups that are attached to this is a chiral center. So these are similar kind of groups. So now how to define which group is having high priority? So this here we have to define based on the chain length. So here you can see here it is only one chain length, while here the chain length is 1 and 2. So this is a larger group while this is a smaller group. So based on the chain length the priority is divided. So this is having low priority while this is having high priority, and also based on the atomic weight. Clearly it is defined that this CH3 is having less atomic weight as compared to CH3. So you can see here carbon 12 and hydrogens 3. So 12 plus 3 will be 15, while here this is 12 plus 12 24, 24 plus 2 26, 29. Chlorine is having 35.5 while hydrogen is 1. So now if you want to give the priority to the whole molecule, now this chlorine will have first priority, this ethyl group will have second priority, methyl group will have third priority, and hydrogen will be having fourth priority. Even though hydrogen comes in when we draw the imaginary plane, then the hydrogen, even if it comes in between, we have to count only 1, 2 and 3. So here now when we rotate this axis or when we rotate this plane of priority, then we can see it is moving from the left side. It is moving from the left side to the right side. So you can see it is turning towards right side from left to right. So it is defined as R isomer, because if we see the priority, if we rotate it, it will move towards right side, and if similarly if we see So this will be again first priority, second, third and fourth. So now here it is moving in the left side. Here now the priorities is moving towards the left side. Here it is moving towards the right side. So this is S isomer while this is R isomer. So now dealing with the third rule. So what is this third rule? If the atoms attached to the chiral center are isotopes of the same element, then the isotope which is heavy gets the high priority. So let us see the example. Again, this is a chiral center. So we have to define. So here you can see between these halogens, obviously chlorine is less molecular weight as compared to bromine, and here hydrogen and D is deuterium. So these both are isotopes of each other. So now we all know that hydrogen is less heavier than deuterium. So deuterium gets higher priority, while in case of chlorine and bromine has high atomic weight, so it gets high priority. So for the whole molecule, if we define the priority list, then this will get first priority, chlorine will get second, deuterium will get third, while hydrogen will get fourth. So priority is moving in this direction. While in this case, bromine first, chlorine second, deuterium is third, and hydrogen is fourth. So the priority is moving in this way, that is left side, while the priority is moving in right side. So this is R isomer. As it moves in left side, it is having L isomer. So this is R isomer and this is L isomer. So here we define based on the isotopes. The next rule is rule 4, that is a doubly or triply bonded atom is considered equivalent to 2 or 3 atoms respectively. Here we can define it as, if we assume that this is a carbon, this is double bonded carbon and this is triple bonded carbon. So now this is equivalent to, this is equivalent to, it is hypothetically considered, while this is considered as in this way. It is either, if it is doubly bond, then 2 atoms are defined. If it is triply bond, then it is assumed that the carbon is attached to 3 similar atoms. So this rule is hypothetical in nature. So we can consider an example. So if we see this as an example, so here you can see there is a double bonded carbon atom. So now this is a chiral carbon. If we want to assign the priority, so here we can see methyl, as we know, carbon 12 and hydrogen 3. So it will be having 15 as a molecular weight, while this will have 12 plus 2, 14, 14 plus 1, 15 and 16 oxygen. So it will be 31. So now this CO is considered as CO and O because it is double bonded, so it is considered as CO and O. So now here you can see 16 plus 16 because 2 oxygens, so it will be 32 plus carbon, 32 for oxygens and carbon is 12 and this hydrogen is 1. So totally it will be 45. So molecular weight of this is hypothetically considered as 45 and hydrogen is 1. So if we assign the priority, this will have high priority because its molecular weight hypothetically assumed is 45. This will have second, this will have third and this will have 4th priority. So if we assign the priority, then it will be rotated towards right side. So this is considered as R isomer. Understood? Because of presence of double bonded carbon, it is hypothetically assumed that it can be given as 2 different atoms attached to the single carbon. So in this way, the molecular weight of this molecule is increased hypothetically. So this is how the RS system of nomenclature is been assigned, wherein there are different rules to be followed. That is, rule 1 is based on the atomic number, wherein the atom with the high atomic number gives high priority, while the atom with the low atomic number is given the next priority. Here you can see the different priorities, and if the priority list is moving towards right hand side, okay, here I had made some mistake, so it is moving towards the left hand side. So this is moving, we are rotating the molecule in the right hand side direction. So this is R isomer, while this we are rotating the molecule in the left hand side direction. So this is a S isomer. We are not exactly rotating, we are assigning the priority. So now these priorities are assigned in left hand side direction, and here the priorities are defined in the right hand side direction. So this is an R isomer if it is right hand side, and this is a S isomer because the priorities are moving in the left side. In rule 2nd, the priority is assigned based on the similar kind of groups. If the similar kind of groups are present in the molecule, then the priority is defined based on the chain length, and also the priority is based on the atomic weight. So here see the chain length of the two similar kind of groups. Here the chain length is only 1, while here the chain length is 2. So if we assign the priority list moves towards right hand side. So it is an R isomer. So next is the rule 3. Here the rule is assigned for isotopes. The heavier the isotopes gets the higher priority, and less weight of the isomer gets less priority. So here you can see the isotope is hydrogen and deuterium. So because of deuterium high weight, the priority for deuterium is more as compared to hydrogen. The overall priority, if we see, bromine gets high priority, while chlorine 2nd, deuterium 3rd, and hydrogen 4. So if we move the priority list, it moves in left side, so it is given as L isomer, while in this case the priority moves in right hand side direction, so it is given as R isomer. Earlier I said it is R isomer, but this is not correct. The correct answer is L isomer and R isomer. And the last rule is that if the compound contains doubly or triply bonded atom, then it is considered as it is equivalent to 2 to 3 atoms. So here you can see, so this rule is hypothetically assumed. So here you can see the example. This chiral carbon is attached to one of the double bonded carbon atom. So this double bonded carbon atom, it is assumed that it contains 2 oxygen. So hypothetically the molecular weight of this molecule increases. This is the reason that it gets high priority. Then the other atoms present in the molecule get the respective priorities, that is 2nd, 3rd, and 4th. So as this again, if it turn the priority list, it moves in the left hand side direction, so it is known as L isomer. So this is all regarding RS system and DL system of nomenclature. Hope you have understood for the today's session. Thank you.